Hi, everyone. It's Mr. Bauman. We're going to talk about vectors and scalars today. This is essentially an adapted video that I'm going to take almost directly from Khan Academy. So if you get confused about what we're doing here, you can always go and check out this topic on Khan Academy, vectors and scalars, in his physics videos. It's very well done. I'm just doing this version of it so you can kind of see and hear how I will talk about it, so that you can relate a little bit more to what we're going to do directly in class. So hopefully I can help you. If you feel like I totally suck and you'd rather have somebody who's really good at it, go ahead and check out the Khan Academy video on this. Okay, so let's talk about vectors and scalars. Vector and scalar are terms that we use to talk about quantities, values, measured values that can be described in two different ways, as a vector or as a scalar. So here's the thing. They both talk about magnitude, which is just a fancy word for size. So I'm gonna actually just write size as well. So both vectors, hello, both vectors and scalars have to do with magnitude, or how big the measurement is, the size of the measurement, right? Okay. So 6, for example, that's a magnitude. All right. All right. So here we go. The difference is that vectors also require a direction. Okay. And you're going to see an example of that here in a second. Let's draw a picture. Here we've got the grass. Very nice. And we're going to put on top of the grass, I don't know, a box of some sort, probably. So let's build a box. Here we go. Ready? Merp, 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 merp. There's our box. All right, great. Okay, so now you are going to push the box. Let's push the box this color. Push the box to the right. Okay, so this is where the box started. Okay, in position 1. Y. In position 1. And now our box is going to be in position 2. And there's our it's beautiful. Love that box. Okay, there's our box. Okay, so let's say that we measure with a ruler, a meter stick, a measuring tape, a laser measuring device, your eyes. We measure, okay, and we find out that the box has actually moved a distance, and that distance we'll call from the center of this box. We're going to call it 5 meters. Okay, for the sake of this problem, I swear I can draw a straight line. There we go. 5 meters. And I'm going to use M as the abbreviation for meter because y'all know that's what we do now. Since you saw that, that's lovely. Okay, 5 meters. All right, our box moved 5 meters. Now, 5 meters tells us something. It tells us the size of the distance, right? It tells us how far the object moved. So that 5 meters is actually distance, right? How far did it move? It moved 5 meters. And I can't write letters. So let's delete that one. Okay. Now, distance is actually a scalar. There you go. You got your very first scalar property, your very first scalar quantity, distance. Distance is a scalar. It's the size of the length that something has moved, or the length of a path that's taken by a thing. Okay. Now, let's say that instead of just saying 5 meters, you then wrote 5 meters, which is the distance that something goes. That's the magnitude, right? That's the size of the distance. The size of the movement is 5 meters to the right. As soon as you add to the right, you've added a direction. So magnitude, 5 meters. Direction, to the right. Now it's a vector. And what do we call this vector? This vector right here is actually called something called displacement. It's distance with a direction, okay? That's displacement. So there's 2 terms down, and let's keep going. So let's say that now we had our watch running while we were moving our box, okay? So let's say that it took, and again, this is literally directly from Khan Academy, so credit Khan Academy. But I'm using the exact same numbers. Okay, so let's say that it took 2 seconds. That's how long it took in time, okay? So it took 2 seconds for the box to move from position 1 to position 2. Okay. So time is actually, it can be a scalar or a vector because there's no such thing as direction with time. At least we're not going to consider direction with time right now. I understand that like going back in time is like a theoretical idea and all that, but we're just going to call time to be whatever it wants. So I'm never going to ask you is time a scalar or a vector because it doesn't really matter. We're going to just talk about time moving, forward. Okay. So it took we moved 5 meters and it took 2 seconds, right? So what can you do with this? Well, you can actually calculate how fast, right? So let's change to a new color. So how fast did we move our box, right? Well, the box traveled 5 meters. Went 5 meters. And it took us how long? 2 seconds, right? So 5 meters per 2 seconds, right? That's how fast we went. That's how fast it was. So let's simplify this, right? Which we can do. Let's use this color. So 5 meters divided by 2. So 5 divided by 2 is 2.5, right? So 2.5, and it went in meters per second, right? 2.5 meters every 1 second. Do you see how I've done this? If you have questions about this, absolutely just ask me them. Okay. So 5 meters in 2 seconds, or 2.5 meters for every 1 second, right? So we went 2.5 meters each second on average. That's like the average. Okay. And so how fast is that? That's 5.2 meters per second. That is a magnitude, right? Since that's a magnitude, this item is called speed. Speed is a scalar quantity describing how fast something is, right? Now, let's say you took that 2.5 meters per second and you brought it over to this side and you said, okay, we went 2.5 meters per second, right? But which way did we go? Well, the arrow points to the right, right? So we went 2.5 meters per second to the right, right? So let's get my red marker out again and we'll mark this. As soon as you say to the right, you've got a direction, right? So now we've got a magnitude right here, 2.5 meters per second, to the right, and a direction to the right, right? So now we no longer have something called speed. We now have something called velocity. Velocity is just speed with a direction, right? So if you're driving on the highway and someone says, how fast are you going? And you're like, oh, I'm going 55 miles per hour. That's a speed. But as soon as you say I'm going 55 miles per hour north or south or east or north northeast or south southwest or whatever, the direction makes it a vector. Okay. So vector isn't just a villain who has a squid launcher. Oh, yeah. But he's also, or it's also, a thing describing the magnitude or the size of something and its direction. Vectors need direction. Scalars do not. That is the difference.